Welcome to Cosmic Wonder Series. I am absolutely thrilled to share this explainer with you today because we're going to explore something literally mind-blowing. Imagine if one giant pool of water acted like a global thermostat, right? Like a single ocean deciding whether you're going to need an umbrella, a winter coat, or a sun hat for recess. Well, that's exactly what happens. It's this amazing natural mechanism, and by the end of our time together, you'll understand exactly how the Earth's most powerful weather teeter-totter actually works.
Okay, let's dive into this. How in the world can ocean water in the Pacific change the weather in your very own backyard? It's a fantastic question. If you live smack in the middle of a continent, miles and miles away from any beach, it might seem literally impossible that the ocean affects your daily life. But the truth is, the winds and temperatures of that distant Pacific Ocean act like a giant invisible engine. And that engine? It drives global wind currents, which in turn dictate whether your local school gets a massive snow day in February or if your town has a super hot, dry summer drought. It's all deeply connected.
To understand this connection, we really need to look at the master system ENSO. Now that stands for the El Niño Southern Oscillation. It's a really big, kind of scary scientific acronym, but don't let it intimidate you. It's essentially just the official name for the Earth's giant temperature teeter-totter. It represents this recurring climate pattern where the temperature of the water in the central and eastern tropical Pacific Ocean is just constantly fluctuating. Sometimes the water is unusually warm, sometimes it's unusually cold. And just like a teeter-totter on a playground, right? When one side goes up, the other side comes crashing down, dragging the world's weather right along with it.
Now, to really get how this teeter-totter works, we first need to see it when it's perfectly balanced. We call these the normal Pacific conditions. I want you to imagine you've got a really large, really hot bowl of soup. If you blow across the top of that soup, you're pushing the hot liquid to the other side of the bowl, right? Well, that is exactly what the Earth's trade winds do. They blow west along the equator, pushing all that warm surface water all the way over toward Asia. And because that warm water moves out of the way, icy cold water from the deep ocean is forced to rise up near South America to replace it. Scientists actually call this rising of cold water upwelling. So these are our baseline normal conditions.
All right, so let's break down the two wild swings of our teeter-totter. During El Niño, those winds we just talked about, they get super weak. So because the wind essentially stops blowing across our bowl of soup, all that warm water just sloshes right back to the east. This warms up the eastern Pacific and drags a massive river of air in the sky, called the jet stream, further south. But then we have La Niña, which is the total opposite. The winds become incredibly strong, blowing way more warm water to the west and making the eastern Pacific absolutely freezing cold. That pushes the jet stream way up north. So you can see how they literally pull the world's weather in completely different directions.
But hey, where do these names actually come from? Let's take a quick trip back in time. Long before we had fancy modern satellites tracking ocean temperatures, South American fishermen back in the 1600s noticed a pretty strange pattern off the coast of Peru. Every few years, the ocean water would get unusually warm, and it would completely ruin their fishing catches. No fish, no dinner. And because this warm, disruptive water always seemed to peak right around December, they nicknamed it El Niño de Navidad. In Spanish, that translates to the Christ child or the little boy. The name just stuck, and scientists actually use it to this very day to describe the warm phase of our teeter-totter.
On the flip side of the teeter-totter, we have La Niña. Translating to the little girl in Spanish, this name was chosen to be the direct opposite, kind of like the anti-El Niño. So instead of unusually warm water ruining things, the little girl acts as a supercharger for the normal cold conditions. The winds blow harder, the ocean gets way colder, and the whole system tips drastically in the other direction. So whenever you hear these terms on the news, just remember this: the little boy brings the heat to the eastern Pacific, and the little girl brings the deep freeze.
These oceanic changes don't just stay in the ocean, though. They create massive weather ripple effects for all of us on land. When El Niño is in charge, the southern U.S. gets battered with wet weather and crazy flooding, while the northern U.S. and Canada get to enjoy warmer, drier winters. But when the teeter-totter swings over to La Niña, the script totally flips. Suddenly the south faces intense droughts and a much more severe hurricane season, while the north and Canada get absolutely slammed with heavy freezing rains and flooding. It's a perfect example of how one single change in the ocean shifts the atmosphere for entire continents.
But the effects aren't just up in the sky. They are happening right beneath the waves, too. Think of the ocean like a giant cafeteria for marine life. During normal conditions, and especially during La Niña, that upwelling we talked about brings freezing cold, nutrient-rich water from the deep ocean right up to the surface.
It's basically an all-you-can-eat buffet for tiny little plants called phytoplankton. The phytoplankton feeds the fish, and the fish feed everything else. That's exactly why cold water species like squid and salmon absolutely flock to places like the California coast during La Niña. But during El Niño, that upwelling completely stops. The buffet closes down, the phytoplankton disappear, and the fish really struggle to survive. It fundamentally changes the entire local food chain.
So the crucial point is that these events do not happen on a perfectly regular, predictable schedule like summer and winter do. They usually pop up randomly every 2 to 7 years. And crucially, they don't even last the same amount of time. El Niño, our little boy, typically sticks around for about 9 to 12 months. He basically throws his temper tantrum and leaves. But La Niña, the little girl, can be far more stubborn. She often overstays her welcome, chilling the Pacific down for anywhere from 1 to 3 whole years at a time.
Now, the stakes here are incredibly high. 60 million. That is the number of people globally who faced very real threats to their food security during the incredibly severe 2015-2016 El Niño event. These weather patterns aren't just, fascinating science trivia for a test. They impact real human lives every day. The extreme droughts in some parts of the world, combined with devastating floods in others, disrupted the agricultural food supply so badly during that time. To put that into perspective, 60 million is roughly the population of an entire major country, all feeling the devastating effects of the ocean's teeter-totter.
Zooming out for a second, here is the bigger picture on Earth. El Niño generally acts as a global heater, temporarily raising the world's average surface temperature. It can even cause spikes in CO2 levels in the atmosphere, mainly because the tropical droughts it causes can lead to massive wildfires and actually stop plants from absorbing carbon. La Niña, on the other hand, acts kind of like a global air conditioner, temporarily cooling things down. And because these shifts drastically alter agriculture, infrastructure, and storm preparations, scientists are constantly monitoring these ocean swings. Honestly, just being able to predict whether we're heading into an El Niño or La Niña saves the global economy hundreds of millions of dollars. It allows societies to prepare for the wild weather ahead.
Which brings us to where we are today, and a rather provocative question for you to ponder. With the long-lasting La Niña phase having recently ended, leading us back to neutral conditions, the teeter-totter is preparing to swing yet again. Current forecasts suggest we might be heading into a powerful, perhaps even super El Niño phase by mid-2026. So, what will that mean for the storms in your area or the global food supply? Keep your eyes on the weather in the ocean because the teeter-totter never ever stops moving. Thank you for listening to this Cosmic Wonders episode.